Hey everyone, this is obviously section 1.4, which is titled Exponents and Order of Operations. Should be another section where most of this is very familiar, possibly entirely review of things that you've already sort of built a foundation on in the past. Let's dive right in. So, a little definition here of sorts. To simplify a numerical expression, you replace it with its simplest name. So a numerical expression, we're talking about stuff like that, where there might be things to do, things to simplify, and just kind of like simplify it, make it simpler, replace it with its like a simpler representation or its simplest name. The next definition reviews what is an exponent. An exponent, or a power, tells how many times a number, which we call the base, is used as a factor. And factors are things that get multiplied together. So, for example, we have this, which we read as 2 to the 4th power. 2 would be the base, 4 would be the exponent, and so it means that we have this base of 2 used as a factor 4 times, and again, factors are multiplied together. So we do 2 times 2 times 2 times 2, 4 factors of 2 multiplied together. And if you actually simplified this to a final answer, that should be 16. So hopefully there's this is a video, you can't ask me questions, but I hope you have no internal questions in your brain about, the base of 2, the exponent of 4, and this is what it means. So I guess next we're just going to get into the other topic here, the order of operations. So if you have a numerical expression here, and there's many operations that you can see in this expression. You see some adding, some multiplying, a power of 2, an exponent of 2, the 4 being raised to the 2nd power, some subtraction, some division. And so there's a lot of operations there. And if you want to simplify this down to like a final answer, what order would you do these operations in? Does it matter? Yeah, it does. So you should remember that. That should sound very familiar, that there's a certain order of operations that you do to correctly simplify things. And this is an activity that we may or may not have done, or what we may or may not do in class. We might skip it in class. We're definitely going to skip it here for the video, where you might explore all the different orders of operations and whatever. But this should be familiar. This is how a lot of textbooks, a lot of teachers summarize what order you should do all the different operations in. And so at least when I was growing up, or what any textbooks that I've looked at, the acronym, I think, you can call it, is PEMDAS. It's possible that in, whatever middle school, probably Fort LaBeouf Middle School that you went to, you referred to this as maybe GERMDAS instead of PEMDAS. You might, can't write in white on white. So maybe instead of P, there was a G, and instead of just an E, there was like an E and an R. And then the M and D and A and S. But, okay. So it's possible that you could do GERMDAS. But let's run through quick what and this is in order. So what you should look at first is any parentheses or brackets or braces, or more specifically, any operation inside the parentheses or brackets or braces. And this is kind of why it's possible you learned that it was like really a G, because it's not just potentially about parentheses, it's all of these different grouping symbols. So again, you look at the grouping symbols first, it's almost always going to be parentheses. Okay? But again, it's what's in the parentheses, any operations in the parentheses you look at first. The next level would be any exponents. And, in the GERM-DOES acronym, you could also say R for roots, because they would sort of have the same level of importance or the same ranking in like this hierarchy, right? So you would do exponents or roots next. Then, it's like the M and the D kind of together on the same level. You probably remember that this is multiplying and dividing, but it's not so much multiply comes before divide always. These are kind of like the same, M and D, and you would do so in order from left to right. So as far as multiplying and dividing, the one you would do first is, whatever came first when you look at it from left to right. And then the same goes for adding and subtracting. Adding is not always done before subtracting. Subtracting is not always done before adding. These have the same sort of ranking, I suppose, and it depends on whatever comes first from left to right. So once again, it's the grouping symbols or whatever's in the grouping symbols first. Then you would look at exponents or roots. Then you would look at multiplying or dividing. And then you would look at adding or subtracting. So let's run through some examples. Just gonna kind of burn through these relatively quickly. What I do want to say, and what I do want to emphasize big time is, even though I understand that everyone has their own different level of mental math and how much you're comfortable with doing in your head or the number of steps you do at once, I highly recommend being very, very, very conservative with that. Do not do too many steps at once. Write out your work. Write out many different steps, where you only do a little bit at a time, or maybe even just one operation at a time. And if I didn't already say this or make it clear, write out your steps. Write out your work, okay? And so here, what did I do first? Like, if all these operations you see, there's nothing within parentheses or any other grouping symbols, so wouldn't this be the first thing? The exponent. So 3 to the second power becomes 9. So what would happen next? Well, we got subtracting, we got multiplying, we got adding. Wouldn't the multiplying come next? The 8 times 2. And then all that's left is adding and subtracting, but you do it from left to right. So this subtracting happens first. 25 minus 16 becomes 9. This plus 9 drops down just like everything else was dropping down that wasn't done at that moment. And then the last thing is 9 plus 9 is 18. And just like all videos, if I'm moving on too fast, well, I suppose if it's a video, you can always pause it. That's the beauty of watching videos. Pause it if you need more time to write this kind of stuff down. But the next example, you notice how there's a 13 minus 7 in this parentheses, this set of parentheses, and there's another little bit of subtraction to be done within these other parentheses. So again, you do whatever's in the parentheses first. So 13 minus 7 is 6. The 15 just drops down. 8 minus 5, I'm sure I did that in the same step. 8 minus 5 is 3. If you want to keep the 3 in parentheses for a second, nothing wrong with that, but I don't see any real reason that you would need to keep writing the parentheses around the 3. The parentheses here around the 6, I'm sure a lot of people kept that because, now we're about to do 15 times 6. Using parentheses around the 6 is not the only way to show that we're doing 15 times the 6, that we're doing multiplication. You could have dropped these parentheses and just put a times dot, but whatever. So what happens next? What other operations are left? We have multiplication and division. And again, those are the same ranking, but you do it in order from left to right. So that would mean we do the 15 times 6, that's 90. The dividing by 3 drops down, and then that division is what you do last. 90 divided by 3 is 30. Okay? Once again, pause if I move on too fast. Example C. Whoa. Okay, we got some brackets and we got some parentheses. So hopefully it makes sense to you how, when we look at what's inside the grouping first, well, we have this big grouping using brackets. So we look inside the brackets first, but there's multiple things to do inside the brackets. So you have to almost kind of just focus on this and what would come first just in the brackets. Well, we have our own set of parentheses inside the brackets. So what we're going to do first is the 13 minus the 7. Okay? And that's all I did. And if you want to keep some parentheses around the 6, that's fine, but I don't think you need it. And again, we're still technically inside the brackets, the original grouping symbol. So all of this, you need to figure out what would come next in hierarchy. And it should be what? What comes first, division or doing an exponent? Well, doing an exponent, of course, if you follow PEMDAS or GERMDAS. And look, we're still inside the brackets. We still haven't finished the original grouping symbol that we're doing technically first. And the only thing left is the division, which gets us 12. And so we're finally done with all this stuff inside the brackets. Now we can do this multiplication of 2 times whatever we ended up with in the brackets, which is 12. So 2 times 12, 24. Example D. Adding, dividing, multiplying. What would come first? Well, we have multiplying and dividing, but we have to do whatever's first from left to right. I know that 3 times 2 looks like, I don't know, it's begging to be done, but it's the division that needs to be done first. So 12 divided by 3 is 4. Now we can multiply because that comes next from left to right. Then we can add. Adding comes last. Adding and subtracting from left to right comes last. So that is 13. Okay? So yeah, just a small handful of examples where we're just following the order of operations, PEMDAS or GERMDAS. GERMDAS is a little more detailed and a little more thorough, I suppose. So the next couple of examples or whatever we're going to do is about when the directions say, well, let's evaluate an algebraic expression by, like this. If we say, let's do 3a minus 2 to the third power divided by b. We're going to evaluate that or simplify it. You could use that word too here. But in order to do that, they have to tell you what a equals, what the variable equals, or the variables. We have a couple of variables here. So, of course, this example goes on to tell you that a is actually 7 and b is actually 4. So, what are we going to do? We're going to substitute those in. We're going to replace the a with what it actually is, 7. And we're going to replace the b with what it actually is, 4. Once we do that, we can simplify or, evaluate the numerical expression. So again, like I just said, the first thing we're going to do, and again, write out your work. write it out so you can look at it. You can see the progression from step to step to step. Be very, very, very careful and do not be lazy when it comes to how many steps or how much work you are going to write out on the page, okay, on your paper. So all I did here is I plugged in 7 for A and 4 for B. I substituted. Okay. So now that I have just this expression to simplify a number of operations, what would be done first according to GERM or PEMDAS? The exponent. So everything else just drops down as is, but 2 to the third power becomes 8 because 2 times 2 times 2 is 8. What would happen next? We got multiplying and dividing. We got to do it in order from left to right. So I wonder if I went ahead and did these both in the same step. I did. Because we have some separate multiplication. And this division over here is like separate enough where, you know, I can see it's very reasonable to do both the multiplication and the division like in the same step. And then finally, the subtraction. 19 is final answer. Last thing in your notes here for this section would be a quick comparison. So we're still evaluating. You know, I want you to do this, and I also want you to do that, where C is going to end up equaling 5 and D is going to end up equaling 2. Okay? So, I mean, the difference in these two examples should be fairly obvious. This one has parentheses around the CD. This one does not. So it's like, does that make a difference? Oh, yeah. Like, for sure it makes a difference. Parentheses matter, okay? Because if we're just talking about the straight up order of operations and just approaching it from that lens, right? Here, there's parentheses. We have to do what's in the parentheses first. So 5 times 2 is 10. Then we're going to square it, okay? Because again, stuff that's in parentheses comes before exponents. But here, there's no parentheses. You know, we're going to do 2 to the second power, which is 4. Then we're going to multiply. So yeah, there's a huge difference. And the only other thing I would say, like the only other way to explain that or spin that, or the only other comment I would have is, look, when you look at this original variable expression, you know, whether you look at what it became once you plugged in whatever C equaled and what D equaled, so whatever, you look at the original variable expressions, or you look at these, you know, once you replace the C and the D. So the only other way I would describe this and how you should look at this is when you look at this, okay, CD squared, without the parentheses, right, you should be able to look at that and go, what is being squared? The CD or just D? So you should be able to look at that and go, well, only the D is being squared, or only the 2 is being squared, but over here, because of the parentheses, what's being squared is the entire C times D, or the entire 5 times 2. And yeah, that's a huge difference, okay? So that's it, I suppose. Thank you for your attention, and thank you for following along.